HBS course file. We took some notes yesterday. We went back over levels of organization. And then you added the tissue foldable to your course file. We reviewed the 4 different tissue types, functions of those, examples of those. There are some other notes on 121 that are part of that assignment that should be within your course file. But this, what we're doing right now is actually part of 123. This is forensic anthropology, the analysis of the bones. But yes, so you might want to leave yourself page to finish up 121 notes if you don't have those in there yet. All right, so forensic anthropology, you guys are going to be looking at skeletal remains. So a little bit of background as far as some of the items that you're going to be looking at that would be good to have, kind of in the back of your mind. So this is my sketch of a femur. So this is a femur. This is my sketch of a femur. I know it's not a beautiful sketch of a femur because we all know I can't draw. Yes, I know that looks like a butt. I'm very sorry about that. If you can do better, please go ahead and do that. But really quickly, go ahead and sketch that. Including that little bump on here because we're going to talk about that little bump. All right, I'm about to move on. So you can come back and fix it however you need to fix it later on. So lots of words you're going to be inundated with in HBS, even more so than PBS. I mean, that's the nature of anatomy and physiology. So I always, when I have issues with the word, I give myself a little pronunciation next to it to remind myself how to pronounce it. We mentioned this the other day, and keep in mind that sometimes different features can be pronounced different ways depending on what country you're in, what dialect you have, what you've been taught. So I'm not super worried because, I mean, you could probably go and Google how to pronounce condyle and it might give you another answer or something like that. I go by what I think you're going to hear the most and what I've heard the most and try to do it that way so that, it's something a little bit more common. All right, so condyles. So this end right here, this where it articulates with another bone. So hang on, let me have your attention for just a second. So articulate with another bone means where they're going to come in contact with and where they're going to move around with another bone. So this part of my femur right here, these are my condyles. Articulate with another bone means come in contact with, move around, I think I have a better definition of that somewhere. I do. When we get to joints, I have an actual better definition. Articulates with another bone. If you don't know the w/with shorthand kind of thing, then write it out. Do whatever works best for you. All right, so then the other thing that we've labeled on here is, so on bones you'll have these little knobs, these little projections. These are called tubercles, and it actually has a specific name on a femur, but let's do tubercle for now. So a bump or projection on that bone, and something's going to connect there, a muscle, a tendon, a ligament. That bump is a place, a point of attachment for a muscle, tendon, or ligament. All right, so forensic anthropology, you're going to be using those skeletal remains in order to identify a missing person or put a missing person's name to skeletal remains. There are 4 major identification pieces, if you will. So now before you write anything, remember we were talking, or I was talking about, let's do a little something to help our notes make a little bit more sense. So notice how I've got off to the side this, and don't write anything down yet, just listen for just a second. I have off to the side that all of this that I have right down here, this corresponds with notes that deal with forensic anthropology. So you ask a question, you have a homework question, forensic anthropology, you can flip through and very easily see where you've got that those pieces of information. Then our 4 little components that we're going to use for identification in forensic anthropology, notice I've spread them out, and anything that I've written on each one of these pieces of information is off to the side, and it's its own little blurb. So if a question says, well, you know, how can you tell race through skeletal remains? It's easy for you to pinpoint where that is at and then give yourself that information. Spreading them out a little bit more, making it a little bit more visible to you. All right, so for gender, notice that once again, there are 3 bones that can give us information about gender. So I've spaced that out as well. So within forensic anthropology, skeletal remains, we can determine gender from skeletal remains. The pelvis is one bone that can help us determine gender. The shape of the cavity in the pelvic girdle. The skull can help give us an idea of gender. You look at the eye orbit shape. Is it more circular? Is it more cubish, more like a square? The frontal bone of the skull. The external occipital protuberance. And you'll learn about that when you actually do 1, 2, 3. These notes go along with what you're doing in 1, 2, 3. Another bone that can help us tell gender are the long bones. The femur, the humerus. We'll look at the length of those. Did it just shut down on you? Oh. You can. Protuberance. Protuberance. Should be. Protuberance. Something that protrudes out, something that sticks out. Okay, another way we can identify skeletal remains is we can look at the race of those skeletal remains. The skull and the femur are bones that can help us identify, narrow down what race these individuals are. So for the skull, you'll look at nasal guttering, you'll look at the nasal spine, you'll look at the nasal index. For the femur, you'll look to see if and what kind of curvature the femur has. So for race, you're going to look at the skull. You're going to measure and compare the nasal guttering, nasal spine, nasal index. The femur, you're going to look at the curvature. For height, you can apply equations to the size, to the length of the long bones, and that'll give you an idea of the height of that person. That can also help you narrow down information in terms of, what's missing person we're looking at. Then finally, the last piece of information we can get from skeletal remains is age. The pelvis or the long bones can help us with age. So for the pelvis, the epiphyseal union and that cartilage, we look to see if that's fused or not. Epiphyseal union, we look at the cartilage in the pelvis. For the femur, tibia, humerus, for those long bones, we look at the trochanters, the condyles, the epiphyseal union, the growth plate. And like I said, these things are going to make a lot more sense when we actually do 1, 2, 3. So for the pelvis, you're going to look at the epiphyseal union, the cartilage within the pelvis. For the femur, tibia, and humerus, you'll look at the trochanters, the condyles, the epiphyseal union, the growth plate. Pelvis, you're looking at the epiphyseal union, the cartilage for the femur, tibia, and humerus. You're looking at trochanters, condyles, the epiphyseal union, growth plate. If these things tend to blend in or you can't tell where they go, you can always draw lines. Whoops, that wouldn't be the right line. Draw lines in between each one of these straight across so that you can see which component goes with which, or which information goes with which component. Yep, femur, tibia, humerus. I would suggest a big post-it note. I mean, you don't have to, but I'll show you why here in just a minute. So HBS, Human Body Systems, is about organ systems. So since we're going to be looking at some of the same organ systems that we did before, but a little bit more in depth, so sometimes a post-it note might help you get right to where you need to be within that section. And so I would go ahead and leave a couple pages for your forensic anthropology stuff, your notes, worksheets, conclusion. And then, so I've got my skeletal system set up, but then this is that post-it note that I had over there. We need the functions of the skeletal system. You can write them on that side. You can write them on a post-it note. You can do it however you want. Just make sure that you know, and I've kind of sort of combined a few of those on here, what the functions of the skeletal system are. So function is the job, the purpose, what we need the skeletal system for. Skeletal system provides support and protection. I'll send you the stuff that we did. We are just now working on the next set of notes, so HBS course file. So flip in your HBS course file. So I would go one more page. I would skip that page because 121 has some notes. Now those will be the forensic anthropology notes that I just gave you, so flip a page. Then you have forensic anthropology stuff from 123, so skip a page. And this is where we're at right now. So I would just, don't worry about it, just write that directly on that left-hand side page what those functions are. Mineral storage, I mean, calcium especially. Strong, healthy bones. But the thing is that we get calcium from our bones and we put calcium into storage in our bones, and there are other minerals as well. Actually, there's fat storage in our bones too, but I don't think we're at that level, so I'm just going to worry about the mineral storage. And then our bones make blood cells. Red blood cells, white blood cells, platelets. Okay, these are notes on our skeletal system. We talked about levels of organization yesterday. Oops, organ system. We also took that down a few more notches, but for right now, we're not. I mean, because when you get to organelles, molecules, and atoms, that's basically going to be the same no matter what organ system you're looking at. Those levels of organization are going to be relatively identical. Okay, so the organ system that we're looking at is the skeletal system. Any idea what organ we might, give me an example of an organ that together would create that organ system? A bone. So we don't normally think of that. We think of bones being just, inanimate rock kind of stuff. But a bone is a living structure in us. It's an organ. It's just like a heart or a blood vessel or something like that, or a muscle. So the organs for the skeletal system are the bones. So I gave you an example, the humerus. Right? So the tissue that we work with that creates our bones are either spongy bone or compact bone. Well, that's examples. Spongy bone, compact bone are examples of tissue. And the cells for the skeletal system are called osteocytes. So an example of a cell is an osteocyte. A bunch of osteocytes together are either going to create spongy bone or compact bone. Those tissues together can create a bone like the humerus. The humerus would be part of a whole bunch of other bones that would create our skeletal system. Osteocyte, spongy bone, compact bone, humerus, skeletal system. Osteocyte, spongy bone, compact bone, humerus, skeletal system. All right, so next we're going to look at the types of bones. You can use a highlighter, you can underline, whatever, make it stand out so you know everything down below that. This section is notes on types of bones. Then, once again, just giving you an idea, hang on just a minute, don't copy this down because I'm just showing you how things are set up. So as I took these notes, I separated them out. I drew a line in between each one so I know all of this information right here goes with that. But this makes it a lot easier. So I ask a question in class, I draw your name, and I said, give me an example of a long bone. You can come over here, flip, 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 types of bones, long, and you've got it right there instead of reading a big, huge chunk of information and trying to find it within that big, huge chunk. You got to make things easier for yourself. All right, so one type of bone is a flat bone. Makes sense that they would be thin, they'd be like sheets, they'd be flat, but they're not all like a piece of cardboard flat like that. They might just be a thin sheet. Like your skull is an example of a flat bone, but we would never think of a skull being flat. It's just its structure is like a thin plate sheet that's curved. The function of flat bones are to protect internal organs. And then notice I left a little space there, and I've got EX that represents example. So examples of flat bones: skull, sternum, ribs, ilium, ischium. Hopefully those terms sound familiar to you from Christmas credit. So a flat bone is a thin plate or sheet that protects internal organs, like your brain, heart, and pelvic organs. Examples of flat bones are skull, sternum, ribs, ilium, ischium. Another type of bone is a long bone. The function, the job, the purpose of long bones are to support your body weight and help with movement, because long bones are going to be the ones that are attached to our skeletal muscle. Examples of long bones are the humerus, radius, ulna, femur, phalanges. I mean, the phalanges don't seem like they're very long, but they are long bones. Purpose of the long bones is to support body weight and allow for movement. Examples: humerus, radius, ulna, femur, phalanges. right, then we have short bones. These guys are boxy, cube-shaped, chunky kind of dudes. They help to provide stability. So our carpals and our tarsals are good examples of short bones. They help to stabilize those joints. And then finally, irregular bones. So they're going to be irregular. They're going to have different shapes, so they're going to have a variety of shapes. They might be complex, so they're not just this big long bone. There's a little bit more to them, so they can be complex. Your vertebrae and your sacrum are some examples of the irregular bones. This is Mrs. Johnson. Hey. We're right in the middle of notes. We won't be down there for a few more minutes at least. Yeah, we usually go to break at 10:10. It's today? Oh, okay. I'm sorry. I didn't even know that. All right. Okay, sorry. All right, bye. How did I miss that? All right, we got this. All right, next we're going to put in a feedback loop for calcium in our bones and stuff. So make sure that you just, we'll take a whole page for that, not a whole sheet, but a whole page. But we'll get to that in just a second. So that's what's over here on this side. Okay, so next I have the picture of the bone that I just gave you, and then I've got it like a little door here so that we've got information underneath that we can identify each of these parts of the long bone. And so notice that, like, this is what I'm taking this whole page for. So I've got information for the long bone is about 2/3 of the page, and then we'll talk about osteocytes at the bottom. And that's all I have on this page. Notice when I taped it in, I've got my numbers over here on this side, so I can kind of quiz myself. So number 1, I find number 1 on here. Do I remember what number 1 is? Number 3, number 7, etc. All right. So number 1 is this bracketed area right here, bloopity bloopity bloop. And so that represents the proximal epiphysis. That's the proximal epiphysis. Number 3 is the distal epiphysis. Epiphysis is the term that we give to the end of a long bone. All right? Proximal, distal. What's the difference between those two terms? Okay. Not necessarily. We got to kind of watch that. I mean, I know what you mean, but not necessarily. Distal, distant. Okay, so when we look at proximal and distal, we're looking at points of attachment. So the proximal is the part that's closer to the point of attachment. Distal is the part that's further from the point of attachment. So when we look at these two epiphyses, proximal, distal, closer to the point of attachment of the body, further away from the point of attachment to the body. All right, number 7, this section right here, that's the diaphyses. Diaphysis, not ease, diaphysis. Epiphysis, diaphysis. Okay, so that's the body, the shaft, middle part of the bone. Number 11 is the growth plate, the epiphyseal line. Guess I need to scorch that. We're going to look at some x-rays. We're going to look at some pictures when we do our forensic anthropology, and it's going to make a little bit more sense. You'll be able to see it a little bit better when we talk about that. And we'll set that stuff up tomorrow. The growth plate is where you have bone cells that are still making new bone, where your bones are growing. Once you get to a certain age, that growth plate fuses, solidifies, and you don't have that anymore. And that's one of the reasons why we can use the presence or absence of, or the size of a growth plate to kind of give us an indication about age for our forensic anthropology. All right, numbers 5 and 10 represent cartilage. The purpose of cartilage is to hold bones together, to help protect the ends of the bones, help with that movement and cushioning within those joints, and it absorbs shock. I mean, it absorbs a little bit of shock. So cartilage holds the bones together, it absorbs shock, it helps to protect in those areas where we've got movement, and it's going to help cushion those joints. Cartilage holds bones together, protects, so that's my movement, that's my abbreviation. So it protects in those areas of movement, helps to cushion those joints, helps to absorb shock. Number 9 is called the medullary cavity. The medullary cavity. This is where yellow bone marrow is at. So number 9 is the medullary cavity, and that's where yellow bone marrow is. Okay. Number 2 is called the periosteum. The periosteum is actually a membrane that's on top of that bone. So it's a membrane, it's a covering, and it helps to protect the bone. So number 2 is the periosteum. number 8 and number 4. So number 8, spongy bone, number 4, compact bone, and we actually go into that in a little bit more in depth. Okay, so that's all our bone structures. Oh, no, I wrote that on there, didn't we? Yeah, we kind of already put periosteum up on there. I don't know why I repeated that. Okay, so next, bone cells. So on the side over here, osteocytes are bone cells. And there are 2 types of osteocytes. So you ask a question, which is the type of osteocyte that builds bone? You got it, bam, bam, you can find it real easily. Osteoblasts build bone. Osteoblasts build bone. So you're always trying to look for something that's going to help you remember. So if you can remember osteoblast builds bones, then you can remember that osteoclasts do the opposite. They break down bone. But I use collapse to help me remember that osteoclast collapse. So that helps me remember it breaks down bone. There are lots of triggers to get these things going. So we can have cell signaling, like hormones. So hormones, growth hormones are produced. They wash throughout your entire body, but they're only going to attach to specific receptors that are meant for them. And then that growth hormone can cause more bone, can cause those osteoblasts to be going and lay down bone. There are other hormones that can stimulate the osteoclasts to remove bone, to break down bone. You can have environmental pressures. So when stress is applied to a bone, then that's going to stimulate the osteoblasts and they're going to build more bone. So people that are weightlifters that lift huge amounts of weight, then they're going to have thicker bones in order to be able to stand that. And the way that they did that is they build it up. That pressure over time helps that out. Hyperplasia is the last term that I put down here, and it really doesn't go specifically with this. I mean, hyperplasia can apply to lots of different organ systems. What does hyper mean? We're going to increase, we're going to speed it up, ramp it up, we're going to have more. Plasia is translated formation, and especially when we're talking about cells. You can have hyperplasia that deals with muscle cells. So hyperplasia, left ventricular hypertrophy, hyperplasia, that's when that muscle tissue builds up too much there. You can have hyperplasia with your bone cells. So the outside of this bone is compact bone. The inside is the marrow. So the outside is solid and hard. The inside's a little bit softer. So if you have hyperplasia in your bones, then you've got, like for sickle cell. So sickle cell disease messes with your red blood cells. Does that sound familiar? Turns them into the sickle shape. They don't last as long. Sound familiar? Okay, so since they don't last as long, they have to be replaced. So blood cells come from your bones. Oops, I guess it would help if you saw what I was pointing. Blood cells come from your bones. And so if we're ramping up production of our red blood cells, then you're going to have more tissue in there in order to create them, more cells to create the red blood cells. So you're going to have hyperplasia within your bones. And if all that pressure is pushing on the bones because we have extra tissue in here, then that's going to really hurt, because a bone is not a dead, unfeeling thing. It's got nerves and blood vessels and stuff that's running through it. I know people who've had leukemia, and leukemia affects your white blood cells, and they have lots of issues with pain in their joints and bones and stuff like that because of what's going on. All right. Because of what time we have, let's just go ahead and do that. Okay, before you write anything down, listen to my melodious voice for just a second, and then I'll let you copy it. Okay, what kind of feedback loop do we have? How do we know it's negative? Has a general figure 8 shape. Negative feedback loops, one stimulus causes an opposite reaction. Stimulus causes an opposite reaction. Okay, so let me walk you through this, and I'll let you copy it. So Ca+, that's calcium. That's our calcium ions. So you have an increase of calcium. I don't know. You drink hot chocolate with milk in it. You eat something. You have a big old chunk of cheese, whatever. You take a vitamin. You increase your calcium intake. Yay, it goes into your blood after running through your digestive system. And it's picked up by sensors in your body and realizes there's an increase of blood calcium. Your thyroid gland then is going to release calcitonin. Calcitonin. Calcium in. Calcitonin. So that hormone affects your bones and affects your kidneys. It tells the calcium, it tells your bones to put calcium into the bones, so more calcium is stored. It tells your kidneys to stop hanging on to calcium. We have too much, you need to go ahead and flush it out. It needs to be part of the urine. Calcitonin puts the calcium into your bones and tells your kidneys to stop holding on to excess calcium. We need to go ahead and get rid of it. So your osteoblasts are activated, and they are incorporating that calcium reabsorption back into the bone. Osteoblasts build bone. So now that we have all of this calcium, the calcium sent to the bones, osteoblasts build more bone. Because all of that calcium is being stored in your bones, because your kidneys not hanging on to it, is flushing it out, your blood calcium levels drop. Let's say it's been a while before you eat, you have a disease, that kind of affects you, something that's making your calcium levels drop. This can even be something normal. It doesn't even have to be a disease. So we don't eat every second of the day. You're not chewing on cheese every second of the day or drinking milk every second of the day. So there are times within the day even that your blood calcium levels are going to drop. And that's a problem, because calcium is very integral in neurons, in muscle firing, in your nervous system, among other things. So, muscular system, among other things. So we need to have homeostasis with our level of calcium. We need to keep it the same. So if it drops, then our parathyroid gland kicks into action. Parathyroid gland is going to release PTH. PTH is another hormone, parathyroid hormone. That hormone affects our small intestines and tells it to absorb more calcium. We need to hang on to calcium. It affects our kidneys and does the opposite. It tells it to increase uptake, hold on to any calcium. Then it affects our bones. And within our bones, it tells the osteoclasts to start breaking down bone. Because calcium is stored within that bone matrix, we break that down. We're releasing more calcium back into the blood, and those levels rise. Okie doke? All right, so now you can go ahead and get this into your notes. And then as soon as you're done with that, I'm done with you. Apparently they have hot chocolate in the break room.